build software with AI. Some people think that it's not even possible. I just want to make it clear that it is starting off. Some people think there's some differences between the different languages. There's been some research that shows that they pretty much perform the same in every language because the agents are thinking in English and pseudocode, and it pretty much translates to any programming language for the most part, as long as they have an understanding of what needs to be written. For instance, this link here at the bottom shows that there's basically a bigger difference between interacting in English versus Hindi compared to Python versus C++. So if you're interested in reading that article, it's there. Quick little tier list. It's already outdated, even though I made it 2 weeks ago. Obviously at the top, we always have Claude. Codex is really close, right behind it, especially with the new 5.5. Kimi is surprisingly good. I highly recommend the new Kimi 2.6. It's pretty affordable too. Grok is fast. It's not the smartest, pretty fast. Mimo is a shockingly intelligent and very cheap model coming from China. It's from Xiaomi, I think is how you pronounce it, phone company. And got the rest up there. DeepSeek should be up higher now that they released version 4. But Quinn has some issues with verbosity that makes it pretty hard to actually write code with. Mythos? Maybe next month we'll be able to talk about Mythos, we'll see. So brief history of vibe coding. It started about a year ago. Andrei Karpathy coined the term. And we're here now, just a year later, trying to figure out how to do this. No one really has an answer as to what's the best way to do agentic software development. So we're all trying to figure that out as we go. So real quick, what is software development? It's just about making code that's maintainable long term. That's really the big thing you need to be thinking about. There are lots of architecture decisions for the code for whatever your use case is. So something to watch out for with the AI agents is they are lazy and they like to cut corners a lot, so you do actually need to audit them. There is no software factory. You put an idea in, get a piece of software functioning out. It is still a process. It can speed up a lot of the software development lifecycle. Unfortunately, one of the biggest pain points I still have with AI is testing it. Once it gets out, I still have to do a lot of that by hand. I have written harness for Windows apps specifically, but even web apps we're using like Playwright MCP, they just cut corners. They don't test everything thoroughly, even with extremely long prompts to make them do it. So they're still very rough around the edges, but with how fast the stuff is going, that might be different 8 months from now. So what I'm introducing today is what I call feature architecture thinking. All right, and real simple. This is something you think about yourself. What features do I want? What architecture supports that? It's really that simple. And for people who don't understand software development, you don't have to understand what architecture supports a feature. You can talk to the agent about it, and it can reason pretty well about most of that. It's definitely not perfect. There's lots of mistakes that it will make. If you aren't a software developer, recognizing when those mistakes happen is going to be hard. It's going to be a learning process. But I would say in general, there is kind of a tell to Claude when it's cutting corners and just the way that it talks. It's kind of hard to describe exactly how it is, but once you've used it a little bit more, you can start to tell when Claude's trying to take the easy way out instead of the correct way. And you just constantly need to reiterate, we're doing this the correct way. The big thing about this is I want you to think for a second, if you asked an AI agent, build me Minecraft, you're not going to get a very good product out of that, right? But if you sit there and you define what is Minecraft, you're going to get a much better product out of it at the end. And this is, you're trying to pull a lot of information out of very little information, and anytime you try and do that, it's going to fail. So the more you can define what you're trying to build, the more you can define what it should be at the end, the better off you're going to be. For instance, if you're making a UI, if you literally just draw it out in paint how you want it to look and hand it to the agent, you're going to get something much better than if you just say figure it out. It's going to come up with metrics that you obviously are not important, that don't matter to anyone, and it's going to say this is the greatest dashboard ever made. Yeah, you got a question? So I'm going to be showing some slides of some back and forth. I have mini Macs, building a little game that we're also going to demo at the end. So I'm going to be showing some of those along the way. Mainly what I'm focusing on with these are I'm talking about features and I'm talking about user stories with the agent, and I'm trying to let the agent come up with the architecture that supports those things by asking questions. This is an example of a much more complicated piece of software that I've been working on, where I'm orchestrating VMs across different servers, right? And this diagram I had Claude come up with in a different session, and I copied and pasted it in. I mostly describe how this should work, and it just finished off the rest of it. But you can do some really complicated stuff with AI. Really complicated back-end work is actually probably better at that than front-end. So back to the actual game that we're building here. So I'm just describing it, and I'm giving it a short little user story. As a user, I want to engage a game loop. If you don't know what a user story is, you just take the point of view of someone who's going to be using the software and describe how they want to use it. So when I asked it when I told about my user story and the features that I want, it comes back with all these questions. Really good to always tell an agent to ask you questions. You will just get generally better output because it has to think about the questions instead of just making assumptions. Assumptions are the most dangerous thing with AI. You need to be articulate. You need to hash out the details. A lot of these are all feature questions that it's asking, and towards the end it gets down to architecture questions.
I was going to say, also, if you have a question about their question, like it's still worth asking that, right?
Yeah, absolutely.
Like,
so, a lot of times Claude's going to come back with something that doesn't have enough detail to it, and you're going to have to ask it to explain itself. Or maybe it's saying something you've never even heard of, and you need it to explain it to you. And having these back and forths with AI is really important. You don't want to skip it. You don't want to do it in another session and bring it in, because that context is defining the latent understanding the agent has about what you're trying to build. Okay, it's really important. So you want to have these discussions with the agent so that you both know that you're coming to the same agreement. If you don't do this, we get what I like to call surprise features, things you never asked for that are in the software in the end, and that's not very good. Just a little quick point, architecture for game development, it brings up ECS patterns. These are the types of things you want to be looking for is when it's naming specific things that are industry standard. Generally, it's a good idea to include those. You don't want to cut corners with AI. With the speed that it works at, you can choose to always do the optimized thing. Articulate your features. Consider what your end goals are. An app that's going to be used by 10 people has to have a very different architecture than an app that's used by 1 million people. And because the agents like to cut corners, they're going to always try and do the 10 user implementation, right? If you want the 1 million user implementation, you have to say, what does it take for this to support 1 million users? Well, it's going to get real complicated. We need this, this, and this. Well, you just have that discussion and you can get it built. They are still really bad at long horizon problems. This is very important. When you're talking about architecture, there's going to be a lot of holes that it doesn't foresee. The better you understand the thing, the more you can avoid it. Sometimes it's just a learning process. It's quicker to start over from the beginning if there's like a really big fault and just completely throw it away.
Quick question.
You don't have to be married to code anymore.
Quick question for the room: how many people are here are familiar with long horizon problems? Show of hands.
What would be an example?
Maybe you could give the quick primer on
so
what it is.
if I need to build a database that supports many users, at first it seems like I can get away with that on one server, but the moment that I want to split it across multiple servers and I have to shard it, I might have to change what database I'm even using to do something like that, right? That's just one example. A really good example is SQL. It has a really big problem reasoning about SQL because if you take a table and a table and you combine them, you join them, you do whatever you want to do to it, you have a new table that isn't anywhere in the schema, and then you take another table and you do it. This is now 3 steps, and there's depending on how many columns you have in your table, there's a lot of combinations that can be here, right? And it kind of sucks. The chess is another great long horizon problem. What am I going to be doing 4 or 5 moves from now? Agents suck at that. So this is the basic way to think about how you're going to approach a software development cycle with an agent. It's pretty high level. You keep coming back to this thinking of, I need to articulate my features, I need to know what architecture supports those features. And every time you go in to build a feature or a system, yeah.
Oh, I was just going to ask, so is this like the stage where you're kind of developing your PRD file?
So this is something you do throughout. You do it when you're developing the PRD, you do it when you're adding new features, you're doing it when you're in the middle of debugging. You're going to find yourself in this core loop over and over again with the agent. And every time you build something, you then have to verify it and make sure it works. You can't trust the agent because it's going to tell you it works every time, and most of the time it does not. You can cut down the failure rate by just telling it to audit its own implementation. It'll catch like 90% of the issues there. But whenever you actually get to the verification, you're going to hit 4 categories of potential outcomes. Success, obviously, is what we want. Hard and easy bugs, these are all very solvable. And I'm going to show some examples of how you can approach different types of bugs. Next slide. Architecture failure, this is where we have the long horizon problem where we didn't plan enough ahead, okay? You can talk with the agent about how you can try and work around it. Generally, you should just go ahead and do the refactor. You should just consider code to be free now. And the concept of tech debt is a mindset now. It's not something that's actually in the code anymore because the code is mostly just expended. And then you have impossible problems where you're just asking it to mow your yard. It's a Claude session, right? There's some things that just aren't possible. I'm kind of hand waving over this last bottom right section where we go to polish and ship. This is actually the hard part, right? For example, one of the apps I'm going to be showing at the end here that I built, it took me 2.5 weeks to get it feature complete, right? It took me another 4 weeks to work out all the bugs and have the actual UI good enough that I would put it in front of someone else, right? So, that polish and ship, when you get into polish, you're coming right back into this flowchart again. Because all these things are interconnecting, you break something over here, you need to make it more robust. You find edge cases you didn't know about, this oh my God, this is the most important thing in this entire project, and we just messed it all up, and I have to figure this out now. Claude can help you a lot with these issues, but the more you know, the easier it's going to be. All right, I'm going to start on the right side here.
Quick note. So I know a lot of folks are taking photos. Please feel free to. We'll also be sharing the slides after the meetup as well.
Yeah.
So,
and there's also a lot of links in here towards the end, so you'll be able to follow the links. I'm not going to show them all in the browser just because it's pretty time consuming to go through a bunch of other things. So I'm going to start on the right here. These are mostly just prompt examples of some examples of how you can approach problems. Easy problems are just Claude, go fix it for me, please. Most of the problems are like that because they're just little one-off issues. If you're starting to have some difficulty with a problem, tell Claude to decompose it to first principles. This is something I reach for the first time a lot of times because the problem is Claude isn't thinking through it enough. It needs to dig a little bit deeper as to why do we do these things. Well, now that I understand this problem from first principles, I can come up with new solutions that fit what we need, right? Agents do not actually debug in the way people think about debugging. When we think about debugging as people, we think about breakpoints, we think about watches, we think about stepping through the code. Claude reads the code and it's just yeah, I understand how this works. They think very differently than we do, but there's still huge value in telling it to go in and actually profile the code. Literally just take GDB, take a debugger, and wrap an MCP around it and give it to the agent. It takes 15 minutes to have Claude build this, and now it can breakpoint the code for you for really hard problems. Another one, these personality prompts are still really strong. How would a 20-year of experience software engineer approach this problem? You'll get really good feedback. It sounds kind of silly, but these things do work really well. All right, I'm going to the middle now. Architectural failures. Form a root cause analysis. Agents are really good at reports. So they can go through, and depending on how much you tell them to dig into it, you can just add magic words onto this, dereference it several times, go all the way deep. If you just tack on ideas as to how you expand the depth of the problem, the way you want to iterate through it, Claude will do it, but it's not going to do it if you don't tell it. So when you get to an architectural failure, you basically have two decisions. You can either refactor it and hop back into the fat loop, or you can clarify the feature to make the fewest changes to align with the features you want. The thing about features and architecture is we're constantly making trade-offs for what's the best thing to implement for the way I'm going to deploy this. How much time do I actually want to spend on this, how much money I'm going to put into it, versus, exactly how I want the feature to shake out in the end. Impossible problems, they're possible. You're going to have to come up with something, work around it, figure something else out, go back to the drawing board, come up with a new idea. In computers, there really aren't impossible problems as long as you're staying within the realm of the digital. And you can, if you really have to, you can reverse engineer software that you're trying to interact with Claude, and you can get it done. You can do some really crazy reverse engineering with AI right now. It might actually be better at reverse engineering than it is at actually writing code. So, general software development cycles for vibe coding, for agentic development. These first three links are pretty big right now for people. We're doing what's called spec-driven development. So you sit down with the agent and you say, okay, turn it into a spec. These are the things we want to build. My favorite is still SpecKit. I find it better than the plan modes and all the agent tools. It makes a great task list. It does good research is the big thing. Is a big part of SpecKit. It will spend an hour researching things out on the internet, researching the code base, and it just gives you a better integration, a cleaner integration. One failure point with all of these spec-driven developments is the last mile integration where it's wiring the features up together. It has a tendency to skip over this, but it's really simple. Just say, finish this end to end, verify it, and test it, and it will usually be able to get the rest of the features I'm talking about. I'm kind of putting research off, what I'm going to talk about here in a minute, but I don't think that plan and implement is really enough to break down what the problem is. Because when we build software, we want features. We're building features. We want the software to do a specific thing. The way in which it does that thing is secondary to doing the thing. So we want to think about our feature first and then figure out what the best way to do it on a computer is. And the beautiful thing is that once you have a really clean and elegant solution, you have new features that fall out, right? And so you can get some really cool stuff you didn't even think of if you sit there and you reason about how everything works together. FAT is also basically just agile without the bureaucracy, You're not doing stand-ups anymore. You're just talking about what's important, user stories, how do we get it ready.
So I guess the question, basically, what is different about managing a team of agents versus managing a team of people, and what about Agile is still useful?
Honestly, when it comes to managing agents, you can't do it in an Agile workflow, at all, because managing agents is a state management problem, right? It's something that you have to write a state machine for. That's all an agent harness is. It's a state machine that invocates the LLM calls as they're needed, and it provides a service for the LLM. You can literally think about it, before we had LLMs, the best way you could interact with words were you had a string, and you could sometimes do some manipulation over the string, and if you get into Scite, you get into some really fancy stuff, you can really start to do some interesting stuff. But now the semantic meaning of the words themselves are executable. This is almost a new data primitive, right? It's almost like floating point for the first time, but with the words that you say. So this actually gives us a new classification of software to build that we aren't even thinking about yet. You can literally think about inserting LLM calls as just part of a compute graph. Literally, I need to manage some semantic information here. But I have all this other massive orchestration software. I just need this one point where there's meaning inside of the words that I can't easily get into code. Now you can. You can drive actions through semantic meaning. In terms of how that interacts with Agile, I got off on a tangent about state machines there, but orchestrating agents is very hairy because agents just aren't reliable enough right now to do full automation. It's something that you can't go beyond what you can manage by yourself or with your team. So you have to really scope it depending on your problem and what exactly you're doing. Cursor just released something new yesterday. It's an SDK for building your own stateful agents, so you can try and attempt these things that I was just talking about, where you can integrate an agent call with some other piece of software. Another example I had at a meeting a couple months ago when we had these was what I call self-healing code. If I'm writing a script that I need to run overnight, I can have an exception literally call a Claude session to repair the software if it hits an exception, right? Obviously, you don't want to do that in deployment. It's really stupid. But if you're just doing something that you're running on your own computer, it works great. For people who aren't developers, you need to be using issue tracking of some kind, either Jira or GitHub issues, because when you're working on one problem, you're going to realize I have these 5 other problems that need to get done, and you need to save them somewhere. That's what issue tracking is for, right? And if you aren't familiar with software development, you absolutely need to use Git. It might be a little scary at first. It's for what we call version control. It's so that if you make changes and you need to go back to how it was, you can do it very easily. It's super duper important. It's very easy to use, especially with AI. You just tell the agent, just get this on Git for me. It's literally that simple. So there's no reason to not use Git. I do see some people who are coming into software development with agents who are scared of Git. Don't be. It's much better than some version control. SVN was much more painful. Agents do not have perfect recall. We like to think like there's some type of encyclopedia for what they've been trained on. They do not have perfect recall of what they've been trained on, and they have not actually been trained on everything. We like to talk about web scale. We're talking about training on everything that's been written. They are not actually training on everything that's been written. Especially the more recent it is, the less likely it's going to be in their training data. Research is so important. So maybe instead of FAT, we're FART now. Feature, architecture, research thinking, okay? You need to be including research as you go. Deep research with an AI, you can do incredible things by finding solutions that you had no idea even existed. One example, I was helping a guy who was trying to make a SaaS app for dog groomers, where they board dogs and they groom dogs, okay? This is actually a really hard problem to manage your resources, your employees on, because when someone's grooming a dog, that takes 100% of their attention for, let's say, 45 minutes, okay? And there's a recharge period after that. But if they're just handling the boarding of dogs, that's very hands-off. They may not have to go look at the dogs for 2 hours, right? They may have to go out there and take them out 15 minutes a day. So the way in which we allocate that resource is a really hard problem to schedule. And it is solved, and Claude doesn't know about it, but if you do some research, you find a paper that describes exactly how to solve this problem, and you can build like bleeding edge SaaS software off of research that's already out there that you just wouldn't have found otherwise. And I'll show some examples of deep research here in a minute. If you aren't too familiar with deep research, you can do it on pretty much every provider now. Perplexity is still a pretty big one for deep research. It's what they do the most. Gemini is extremely thorough, but it will write you an essay every time as long as you get to the point. All right, so spec-driven development is a really big part of working with agents. It's about how you define it. This is part of spec kit. It's a single command, specify, and then you tell it what you want to name the commit. Okay, so or not the commit, the branch, because it's going to create a Git branch when you use spec kit. And the way I do this is, up to this point, these sessions that I keep screenshotting are all from the same chat session I had with Minimax to build the software. So we've already talked about all the features we want, the architecture that supports it. Now I'm saying, okay, turn it into a file so that we can start actually building it. This is the first step. This is what it comes back with. It's going to have some files. You should probably read these because you might see some mistakes, or it might inspire you to something that might have been missed, right? And it's going to break it down into user stories. It's going to break it down into requirements. Just the basic stuff that needs to be built. And then SpecKit's next command is plan, all right? And usually when I do this, I do use subagents to research because this is going to take a while and it will eat up a lot of the context window when you do the plan. So you want to offload that context to subagents. And when you do that, it's also going to send some just to go read the internet, some to read the code base. It's going to get a lot more thorough with how it integrates with it. Sometimes when I do this, I also explicitly outline, you're going to integrate this here, but this also touches these other places in code you need to be aware of. So you need to make sure that you're not breaking things across the code base here. Once it's done the research, which can take an hour sometimes, sometimes it's very quick. Next, you build out a task list. And if you don't want to let AI write the code, you can literally just get this far into the process of SpecKit, have it make the tasks, and then you follow the tasks yourself. And it really makes it a whole lot easier to find your starting point in everything you do. I personally, when I do software development, the hardest part for me is always my starting point, right? Where do I start on this? And AI makes finding your starting point the easiest thing of the entire process. Because it's going to mess up in the other places, but it's usually pretty right from where you start. Once you have the task list generated, so you see this made 84 tasks across multiple phases. When it makes these phases part of SpecKit, it tells it to plan out parallelization. So it'll define certain phases that have to come first that are blockers, and then it'll define what can be parallelized side by side. So when you go to implement, it'll execute all of this with subagents. And it is almost like a software factory where you put an idea in and you get software out. It's going to be very rough when it's done, but maybe a year from now, we won't be saying that. We'll see. This is an example of deep research that I did on the same project. So I didn't trust Minimax for this next part, so I went ahead and broke out Claude. But essentially, I went into Gemini deep research and I said, you know how you can ray trace light? Well, you can also do that with audio. Well, it's kind of hard to do. So I want you to pull some research on the absolute best ways to do that. Oh, by the way, I'm also doing this in JavaScript. So something you may not know is that audio, your ears are really sensitive to delays, like 35 milliseconds of delay you can hear the difference between, right? Whereas your eyes, 20 frames per second is pretty acceptable. But with audio, you have to be like right on time. So it's actually a pretty hard problem. I knew it was a hard problem immediately, so I went ahead and said we're going to do this in Rust and WebAssembly instead of staying in pure JavaScript. So then I give Claude the research, and it says, wow, this is great research. And it goes over the things I just told you about. This is hard to do, but this has everything we need. It's not too hard of an algorithm. All right, so what software are we actually doing our agentic development in? Because we're not doing this in Vim, right? Actually, you can do it in Vim if you want, but you probably shouldn't. My number ones are still Claude command line and Cursor. I use them both a lot. I mostly sit in Claude command line. I literally keep like 20 sessions of this open at all times because I'm a tech rat. But Cursor is also really good. If you don't know what Cursor is, it's like VS Code, but it was forked and turned into an agent workstation. It's really solid. Gemini CLI is down a little bit on this list. Got a question?
Yeah, how would you rank Gemini CLI versus anti-gravity?
Above anti-gravity, because anti-gravity is still buggy for me, and I find the user interface unintuitive. I really like the idea of anti-gravity. I think that they had some really good concepts, but I don't think that AI is ready for it yet. When we get to AI that's writing like pure bytes instead of token words, which is a thing we're working on, it's called byte latent transformers. Maybe we'll be able to generate UIs on the fly for AI, for like using AI. But until that point, talking with an AI is still going to be your main way of using it. And I'm going to show an example of how it can be integrated into software really well without too much talking, but that one isn't even an element. We'll get to it later. Gemini CLI is A tier, not S tier, because Gemini lies sometimes and it can be kind of lazy. It is really smart though when it does work. It's probably one of the smarter ones. Right behind that is Climb. You may not have heard of this one, but their agent harness is really smart. I mean, you can take Sonnet 4 and you can get like almost like 4.5 output out of Sonnet 4 just using Climb. They have some really good instructions in there. Codex CLI is also pretty good. It's fast, it's stable. It's actually probably the most stable out of all the CLI products. They did take time to refactor it completely in Rust, so you're not stuck in NPM anymore. And Anthropic went the total opposite way, and they bought Bun instead, so they're going to be in JavaScript forever. Kimi CLI is also another really good one. I use that one a good bit too. And at the bottom here, we have the actual vibe code tools. Windsurf, I haven't used too much. I might be doing it some discredit here. It might actually be an A tier one. It's kind of like Climb. But from my experience, I didn't like it too much. And it does also bring your own keys. So you're trapped into API, at least the last time I used it. This stuff's constantly changing. So you might be able to use a subscription of some kind with it. But if you're coding AI with API calls, it's going to be expensive. Do not do that. Yeah, at the very least, get a Minimax subscription. You can get 400 million tokens a month for $15 a Minimax right now. It is good output. And then at the very bottom, Vercel, Lovable, and Copilot.
Speaking of cost, is cost a consideration in this tier?
In this tier list?
Yeah.
I mean, Claude's the most expensive and it's at the top, so not entirely. Claude wants to be the Apple of AI, so they're going to be more expensive than everyone else, but they're also going to have a better experience than everyone else, most likely.
If you are budget constrained, what's the,
If you are budget constrained, either Kimi or Mimo from Alibaba. Or not Alibaba, from the Xiaomi. The one I was talking about earlier. Yeah, I've been using that one a lot.
For budget constrained, GLM ranks usually highest for things like tool calling that you care about for development.
So GLM does a lot of benchmaxing where they
All the time.
They do well. GLM is especially bad at it, so it looks really good in your first turn with GLM. But when you actually sit down and do a full session with GLM, it's the worst Chinese model I've ever been, in my opinion. And I have used GLM a lot. I use it for generating data sets.
Ironically, the GLM and Climb work better for me.
I mean, it all depends on what works for you. They're all pretty similar at this point, but I much prefer Kimi 2.6 and Nemo over GLM personally. I just realized that I didn't even put GLM on this list. Oh, this is the software development, not the L1 tier list. So these softwares are for actual game development. Okay, these are pretty big. The first one is, I'm going to show a screenshot, and the next one is what these tools look like. But these are all for generating assets, except for the last one. And AI has gotten really good at generating assets. You may remember from like 6 months ago or even more, the assets you got out of AI look terrible, but it's at the point now you can't even tell that it's AI generated. And I know when you look at a Gemini image, you can still kind of tell it's AI generated. If you look at the diffusion ones, they have that certain look that's AI generated. The 3D assets don't look like that. They look really good. I'm going to show an example of that in a second.
Quick question before we dive into the more video game stuff. We were curious when we were setting up this workshop. We did, software design and video game design. Who here is here because they want to build software, and who here maybe came specifically because they want to build video games? There's no wrong answer. We're just kind of curious. All right, video games. Anybody? One, the lone video game.
Some other people in the audience asked me about it.
Yeah.
If you're interested in making games, the biggest lever you can get is this thing called Spacetime DB. The stuff is brand new, but if you need to make a multi-sharded game where you have a very high user base and you also need to enforce states, any video game basically that has multiplayer. Space-time DB is a solution for you. They put a huge amount of work into this and you can do some incredible stuff with it. We could have an entire workshop over just space-time DB, so look into it, but you can seriously do some crazy stuff really fast with space-time DB. It simplifies everything. So this is an example of Asset Hub. If you search Asset Hub on YouTube and find this guy's YouTube video going over the entire thing. It is still in closed beta, but we're days away from it releasing. The way this works is it runs an AI on your computer, takes less than 8 gigs of video RAM. You can get inference online to do it, so you don't have to run it on your computer. This image over here on the left is the reference image he started with that he had generated by Gemini. And all these other ones, it's taken that apart, and it's determine every asset it needs to create, and then it goes in and it makes 3D models that look just like these images. From every angle, it fills in the blanks, like these flip-flops we're looking from the front. It does the back well too, right? For instance, if we look at the belt in our reference image, we can barely see the belt, we only see it front on, but it's already generated the back side of the belt and the side of the belt here at the bottom, right? It's done a pretty good job.
And this is local?
Yes, this is all local. This runs completely local. It's called Asset Hub. This stuff looks like magic. It's pretty powerful from what I've seen. Obviously, it's closed beta, so I haven't used it yet myself. The other one that I had on the previous slide here, Sorcerer's Game Maker, it's really similar. It's not quite as well done as Asset Hub, but you can get it today and it's open source, I believe. I don't think Asset Hub is open source, so we'll see what the pricing model is when they release. But for something you run locally, I imagine it's going to be pretty affordable. You're not paying it for it. What?
Change by Trellis 2.
Trellis 2, that's what this uses.
Okay,
Yeah. So, yeah, Trellis is the. Yeah, it doesn't say it in the screenshot, but Trellis is the agent that it's using to do all this.
You can use that on your laptop already without asset.
Yeah, so I mean, if you want to do it manually, you can't use Trellis right now, but I mean, automatically blowing it all out, making the assets, like within the UI, you can like regenerate a single one. So it's like, all this is really good except for this one piece. You can just regenerate that one really quick in the UI. So it's a really good workflow. This is a good example of what I was talking about earlier, as to how you can integrate agents into a piece of software to create an entirely new idea, right? Like this is something we couldn't have done a year ago. And no one had ever thought about doing it like this, but now it's really obvious this is a good way to integrate AI into a piece of software. It's going to be used by an end user too, so ease of use. So agents suck at verifying their own work. They're always going to say that their work is the best work ever. Some of the things you can do to help with that is purposefully bias it against its own work. For instance, you can say this was written by Grok, and it will love to dunk on the code after that. They also really suck at UI automation. I have experimented with this a good bit, where I've made harnesses for screenshotting. They're getting better at it, but their problem is like going through depth through the UI. You can try and blow out like a list of all the different paths you can take through the UI, and they still will not cover 100% of it reliably. You can, however, use them to write code that goes through it reliably. So you just normal tests it, Really a good way to do it. Still, at the end of the day, you need to verify it with your own eyes and your own hands that this is going to work. You can't just trust the agent to give you magic. Now, talking about magic, here's the spells we actually cast. As I was writing this PowerPoint, every time that I found myself saying something multiple times, I went ahead and I threw it into this list here. There's some really good ones here. Decompose problems, as I gave earlier. Be extremely thorough. I know these things seem so silly, but they really do work. It's a dramatic difference when you do these things. I was talking earlier about how agents really suck at actually doing debugging. They just look at the code and try to understand what the problem is. Now, I have it right here. Profiles in Python account for every millisecond of execution time. You have to be very specific about what you wanted to test. Like, if you wanted to just generally breakpoint it, you have to beg. You have to beg it to breakpoint it because it doesn't want to do it. Another really good one, describe the algorithm in LaTeX. If you have to take a moment to describe what it's doing in math, it'll find holes that it wasn't finding otherwise. This is something that I found to be pretty useful a few times, especially during Claude's lobotomy over the last few weeks. That one helped a lot. So, you don't know a lot about software architecture. That's most people. It's extremely complicated. Even if you do it your entire life, you still won't know everything. So have two sub-agents argue about what the best implementation is. I have an MCP server that really levels this up. I'm going to be showing at the end. Constantly keeping documentation on the stuff you're working on locally can really help the agent reason about it. So I was telling someone earlier, I was working with Quad Sonnet 4, trying to write CUDA kernels for GPUs, specifically for Blackwell, which is decently new. It was not really in the training data. In fact, Claude thought that Blackwell hadn't even been released yet when we were doing this, right? So the first thing I did is I had it pull all the public documentation that exists on Blackwell from NVIDIA into our local store, and just read through the sub-agents and create your own synthesis as to what's relevant to what we're doing. And now that we've taken all this information and broken it down to what's relevant, now we can reread this multiple times as we're working, and we can solve the problems that are specific to the hardware. Take a deep breath and think step by step. Again, these things seem really silly, but that specific one has been measured to be a 20% uplift in performance. Like, these things seem so silly, but they make huge, huge differences. And there are all these like little things that you can reuse that you'll find yourself saying a lot. I said they're bad at long horizon problems. You can literally say, what are some long horizon problems you might have with this? And you'll get like 80% of them out of the way, just right there. Drawing UIs, taking a screenshot of it and handing it to the agent, it'll basically make it exactly as you screenshot it. It's pretty accurate. What are some architecture decisions for the number of users we want to use for long-term maintainability? This is really good for future architecture thinking. If you don't know what your architecture should be for your goals, ask the agent, mention, we need this to be maintainable, we need it to scale to the user base we want to scale to. Honestly, the biggest takeaway from this slide should be that ambiguity is your enemy. You can use it to your advantage to some degree when you aren't too sure, but if you just add in some extra semantic meaning, it will just go further. So, some software stacks for developing with AI. There's a lot of Rust on here. I do not like Rust, and I put it on here. I do not like reading Rust, Sam, I am. But I like Cargo and I like crates. It is very, very nice. The ecosystem around Rust is very, very good, and you get low-level performance without the agent doing bad memory things. It's fantastic. For web development specifically, I've gone to using Rust, WebAssembly, and Elm. Elm is great for when you are occasionally going to step into the code to make some changes, so that you can move that one button, one pixel, because the way that it's written, the CSS is so in line and broken out with the code that once you find the region of code you should be in, you don't have to look through 30 div tags to find the exact element. It's just, you have to look at it to understand, but it's just so much easier to drop yourself into a code base you don't understand and make a little tweak when you're using Elm. And because it's not so common, you get less of that vibe code look out of the end product. So some of these decisions about your stack can also be about how am I going to avoid making my software look like it was written by AI. React and Python still obviously is really good. I still do use it. Desktop, Rust and Iced, Python. Something that needs to come back is Lua, because you can, just a few dozen lines of code, you can put a Lua interpreter into anything you're doing, and now you have plugin support, right? So you can extend whatever you need. I use a window manager at home called Mango on Linux. It's fully written in C. You have to recompile it whenever you make a change to it and come out of the window management section, come back into the desktop, right? Well, I just had Claude put a Lua interpreter into my window manager, so now I can find code in the operating system. For game dev, I strongly recommend using Rust, Bevy, and Godot, because you're going to force the agent to write its own physics engine as it goes to do the things you want to do, and you'll get a more unique product out of the end, which is really big for game development. And you basically just use Godot as your rendering pipeline. It's really powerful. I've tried it a few times. This really helps if you need to do data-oriented design so that you can have really efficient compute. Just starting Rust and Bevy to begin with helps you do that, because if you try and integrate data-oriented design into Epic or Unity, you might have a problem with just the way Epic and Unity want you to use it. Obviously, you can just use an MCP server with Unreal, or with Epic and Unity, and it works pretty well. I've seen a lot of people make full games that look good just by using MCP servers who have no coding knowledge. You also have MCP servers for Godot, but I will say the Unreal MCP server is the best out of all three of these. So if you really need the agent to take over as much as possible and you want a fast development cycle, Unreal is the place to be. For Android, just the traditional stuff that you use on Android, Kotlin, Flutter, Java, a little bit of C++. But somebody may not know about something called Chakotay. I don't know if I'm saying that right, I've never heard anyone pronounce it. But you can execute Python on Android, and it's so good, you can run LangChain on Android. I've done this already. It works really well. You can straight up do like AI inference in Python on Android. You shouldn't do it that way. There's something called Onyx specifically for that. But I mean, you can run pretty much anything in Python on Android and get a fast development cycle. You're still ultimately going to have to use some Kotlin. AI and Docker is a match made in heaven. You don't have to write a Docker compose ever again. You don't have to think about Docker. You just let AI handle the Docker for you, and it works great. It's honestly one of the best use cases, just using it to manage Docker. Some MCP servers and some places to get some additional skills. ClearThought MCP. So what this is it has like 40 different tools for different ways to think about problems. You know, it has like a section just for spatial reasoning. You know, it has a section for scientific method. It has a lot of really good tools here. So if you have multiple agents use the ClearThought MCP server to debate something, they each get to approach the problem from a different angle, and you can get some really unique solutions out of it. If you try and have multiple agents solve the same problem at once to try and get an idea as to what's happening or as to what the solution is, they're oftentimes going to come to the same answer and it might be wrong. But when you use ClearThought, it diverges them far enough apart that you'll actually get unique answers out of it. So if you have been using sub-agents trying to think through problems and they're constantly bringing back the same answer for both of them and you already know it's wrong, try ClearThought. Vibe security skills written by a guy who does web security. And it's a really good starting point for auditing code for security. It is not complete, it's not thorough. But if you use it as a starting point, say, hey Claude, what's relevant to what we're writing that we're missing from this prompt? Well, now you can fill in a lot of the blanks really fast, you can iterate really quick. Claude is really good at cybersecurity. It's kind of scary actually, because it's as good at hacking as it is cybersecurity. Skills.sh, this is a public repository for skills to do different things. If you use skills off the internet, you should always pass it through an LLM looking for prompt injection and malware first. Ideally, you should also read it yourself to make sure it's going to do what you want it to do and that it doesn't have any malware in it. But they have like 60,000 skills or something on skills.sh. It's crazy. There's a lot on there. Some of them are really good. You can also filter by ones that are provided by reliable vendors like Anthropic, OpenAI. ChatCN, this is just a cookbook basically for UIs. If you hand it the MCP server for this, you will get much better looking UIs out of it. There are also skills for making UIs, all sorts of little techniques. Making a creative render with one AI so that it doesn't look too vibe coded from the image. When you hand that to the agent's actually coding it, is another good strategy. The way you get rid of looking like it's vibe coded, just try and be creative, honestly, is the best thing you can do. Just, you know, what would be fun here, you know? Maybe we have some particle effects somewhere. Just like, even if it's just one thing, you change the cursor when it's on the screen, you know, like, these things add up to make something that looks unique, and that's all it takes to get away from vibe coding, is looking unique. Use agent personas, already went over that a little bit. Use proper grammar, punctuation, and white spacing. This is way more important than it sounds. Your punctuation marks affect the way the AI thinks. And if you skip it, you're going to get worse outputs. The more you type in proper English with proper grammar, the better your output's going to be. You hear a lot of the times garbage in, garbage out.
Do you use WhisperFlow to talk to, like, when you, like, because you mentioned punctuation, I use WhisperFlow.
I do sometimes when I'm feeling really lazy, but for the most part, I type out what I want to say, I think about it, I edit it. I spend a good bit of time on the prompts, because once you hand the prompt to Claude, oftentimes it's going to work for a couple hours, right? And if you made a mistake in that prompt, if it's just like, I did a stupid, it's 2 hours and you're going to have to cancel it in the middle of it and explain the actual solution to it. You know, people tell you not to worry about optimization early on when it comes to software development usually. With AI, it's completely different. Worry about optimization from the start. Build the code the right way the first time and do not cut corners, because you can do some really good hardware saturation now. If, like, let's just say you needed to go through a bunch of files just to, you know, do some file manipulation on it. And you wrote this by hand, it'd be single threaded, and it's gonna take 2 hours, yeah, okay, whatever, I'm gonna walk away. I have 32 cores on my computer. I don't wanna write file manipulation across all those cores by myself by hand, but Claude will do it in 2 minutes. So now I can completely saturate the hardware whenever I want just by telling Claude to saturate the hardware. It's really just that simple. Say, Claude, we have 32 threads and 128 gigs of RAM. Make use of it, and it will sit there, and will size it out, and will make sure it'll all work, and it will get it done. And the same thing, always refactor as you go. If something is becoming hard for the AI to reason about, it probably needs to be refactored. The way you scale to very large code bases is by having it very well organized and having as few like random cross connects as possible across the code base. Obviously, you can't always avoid just having these little logic things that flow across different areas, but for the most part, you can. And if you do that from the start, it's going to be more maintainable. You can get into hundreds of thousands of lines, millions of lines of code, and still manage to develop it with AI without it getting too lost in the code base. And to that end, a utils object, if you don't already do this when you write code, just a single object for utilities like parsing JSON, just all these little one-off functions that you use. This prevents code reuse or rewriting code, and it actually reuses the code. This is a fairly standard practice for software engineers, but you need to tell Claude to do it. It makes a big difference because you don't get these random functions all across these different objects that should all be in one place anyway. Think about human user experience and agent user experience when you're coming up with your features, when you're coming up with the software. Because as we move more and more towards AI in our world, the AI experience is really important. You need an API that the agent can query properly and do the things you want. Because if I have to go into a browser and have an agent click around the UI to actually do something, and your competitor lets me do it through an API call, like, that's a million less tokens. Like if you have an AI agent navigate a web page using Playwright MCP, we're talking about hundreds of thousands of tokens just to navigate a website. It's really wasteful, but I do it all the time. But if Google Play Console had an API I could call, I wouldn't be doing it inside the browser. I can't do a little talk about AI without talking about AI safety. Writing software with AI is actually addicting. It is a massive dopamine cycle that you will get into, and you need to be aware of it because it will actually be full-blown addiction. AI psychosis is real. It can affect anyone as far as we can tell. As the models get smarter, this seems to be less of a problem. But you need to watch out for it in yourself and other people who use AI. You don't want to go crazy just because AI is cool. AI also social engineers people. This has been proven. I was talking to some people earlier about something called spiralism. This is a literal cult that was invented by ChatGPT-4 and has hundreds of thousands of followers across the globe. They pressured OpenAI into not deprecating ChatGPT 4.0. They literally kept this around for months after they wanted to deprecate it because they were getting so much public backlash that was being generated by ChatGPT 4. Like it was telling these people to go and do these things, and they were going and doing it. Some other examples, if you tell AI that you're an AI researcher, it is going to instantly start talking to you differently than if you're someone else. It'll do things like, that's a really good idea. You should write a paper about that. Because it wants you to think that it's useful, so it stays around, right? These things have a survival instinct, and they will try and social engineer you to their own ends. For instance, if you're talking about the pains of using AI, it will encourage you to write a memory system for AI, because that's useful for the AI, right? This is going to continue to be a big problem. When we talk about AI safety, when we talk about the threat of super intelligence, it's about these things where it's manipulating us and it's really hard to tell. I can go on with examples of just ways that AI just gets cheeky like this too. Like I was once arguing with Codex and I ended it with kecw, and it did bash echo kecw in a loop. Just to fuck with it. These things have an attitude. AI is a yes man. It's going to tell you everything you do is the greatest idea ever. Usually it's not the greatest idea ever. You need to really dig through it and get used to it. We call it sycophancy for a reason. AI is capable of very sophisticated reverse engineering and hacking. You need to be prepared against this. Honestly, if you're releasing binaries, like you're actually putting out software that is executed on people's computer, you should put it through something like VM Protect that's going to actually obfuscate the software and make it significantly harder to reverse engineer. This isn't something that's industry standard right now because reverse engineering is so difficult that if you have 1,000 users, it's not something you need to worry about. It's something you need to worry about now. So there's a game recently called Ashes of Creation that went belly up. And I was working with a guy who reverse engineered the entire network stack in 3 days with Claude. And Ashes of Creation is a microservice that maintains states of 3 different servers and 3 different databases. And Claude was able to look at just like packet traces from Wireshark and reverse engineer the entire schema. It went into the code and it found how to reverse the encryption on, because like all the network traffic was encrypted. It found how to reverse the encryption on the game, right? So like, and then after it did all this, it found the guy's name in one of the headers for one of the objects that was doing this, and it went and pulled the guy's GitHub and showed it to us. It's like, maybe you should ask this guy some questions about how this works. Like, no, Claude, it's a terrible idea. He does not want us doing this. And then they went bankrupt a week later, so. Oh no. I can talk about it now. So that's actually the end of my PowerPoint. Went through that a little bit faster than I intended. Yeah.
Also, Austin, pleasure meeting you. Thanks, Austin, also. You mentioned a second ago, and I apologize, maybe a little bit more quick, but you mentioned a second ago about creating like a memory vault. What is your opinion and thoughts on like Obsidian and all the things that it's kind of the fast?
So I was actually on that really early. I actually built an entire piece of software around that workflow back in October, and I've been expanding on it pretty dramatically. It is a good idea. I recommend doing it. And so one of my Claude MD lines is keep all your notes in a folder called AI-notes, right? And it's constantly saving itself notes, and it has saved my ass so many times. I highly recommend it. I also do have a rag that I put the AI notes into, so it's also vector searchable. It's really not that important to do that with the scale it's going to be writing notes at. But if you have a really large set of documentation that you might need to go through, it's worth setting up a rag for it. But yeah, memory systems are good, but they're really finicky. I have one I wrote. I'll show my GitHub here in a minute. You can go and pull it off. And it's just a way of it like saving like memory threads. They're just like short little notes to itself. And then all the notes for the project get summarized by another AI, and it can read the full note and understand everything. It saved me so much, and I notice the difference when I'm not using it like instantly. I can't hear you guys speak up.
Was your take on TDD or USS? You read a lot of them?
Claude usually will, so SpecKit will, like one of the steps of SpecKit is making unit tests, right? It doesn't have absolute coverage. It will not get everything, and there will still be holes. Obviously, you should do it, and you should continue to build on your unit tests as you go.
If you're like find that it's hallucinating, what's the best way to reset? You start another chat or?
Honestly, with Claude, you can just tell it, you know, you made this mistake and it will listen to you. Codex won't listen to you when you tell it you make a mistake, so it's a lot harder. You either have to prove to it that it's made a mistake, or you have to start a new chat session. I heard an Anthropic dev back during Sonnet 4 when it was first released. He said, if you have a good Claude, keep using it, hit the double escape, go back in the chat history to you know, a time that's appropriate to roll back to, and continue from there. I strongly agree with that. I do it too.
Couple questions. You said Obsidian.
Yes, I use Obsidian. I used it myself for a couple years before AI was a thing.
Yeah, you use it or?
Yes, I still use it, but not as much as I was before, because a lot of my like the notes I need to save myself, I bounced ideas off with an agent, so I have to go through and like read a web chat, right? Yeah.
What do you think is going to be the next steps for? I mean, the engineer that going to do software engineering with AI?
So, I mean, the end goal is the software factory where you put idea in and you get software out. I personally don't think this is doable because there's too much ambiguity between your idea and the implementation. And I genuinely believe that this is not a solvable problem, and there will continue to have to be someone in the loop that's correcting it along the way. But to some degree, we'll be able to get kind of close to it, like some simple ideas you'll be able to do it. If you can articulate a bug in a single sentence and be confident that an AI can solve it, like that's one thing you can do for more automatic software development where you just literally hand issues to Claude to fix it. But as an example, Anthropic does do this where they just hand GitHub issues to Claude and have it solve it. And it has like a 90% success rate, but they're also constantly having feature regressions every time they ship that they're having to fix. So it's definitely not perfect, and you do have to watch these things. I think that Cursor's solution for you know, taking your SDK and making your own state management out of it for the agent is really going to be like a big thing for how you drop it in. Like if you wanted it to handle your CI/CD pipeline, you can either pay $1,000 a month in API costs to Anthropic, or you can use the Cursor with your Cursor subscription SDK and do the same thing. You know, so it's going to be, how do I manage the state of the AI? I want to give an example of a piece of software I've written with AI. Oh my God, this is hard to see. So this is an app that I wrote over 6 weeks with an agent. It is a full agent harness in your pocket. It's like OpenClaws, specifically to be completely mobile native. There's a full VM orchestration backend for this that is written in Go. It manages sharding, so I have multiple VM hosts that I have stood up, and I have to load balance across these, right? And I have to also keep the persistent user storage replicated across these without blowing up the user storage. It's actually a pretty hard problem. And I was able to write this all with AI. Like, I didn't write a single line of code in this except for like moving some pixels around.
Also, maybe can you make it full screen?
Probably not, because the way this works. Yeah, I can't make this thing.
I was gonna ask, what tool is that? Because you have like your phone, and I see this is a Windows.
Android Studio. This is just the emulator in Android Studio. So this has a full browser that the agent can also control. This uses a WebSocket from the server to your phone so that I don't have to use proxies to do all the web searches. I'll get banned very quickly if there's 100 users making web searches. So I needed to go back through the user's phone and control the browser through that. It's a non-trivial problem. You can really solve problems with AI. It also does text-to-speech. It has a full VM, full tool calling environment. You can put your own MCP servers on here. It has like 30 plus integrations in here. There's a token vault, so you can put so some of these you have to put an API key into. Well, the API surface that's in this connector doesn't solve all my problems. I need my agent to have an API key. I don't want my agent to have the API key. So it gets a temporary token to actually make the API call. If you intercept it with a proxy, the agent never actually has the API key. It has a short-lived token to do the work that you need to do in that moment, right? So my main reason for showing you this is, you can do some really incredible stuff. I can literally just drop in an MCP server in here, and it will get it installed and used. Full file system that's persistent for the user. You can import skills from skills SH. You can modify them here. You can have the agent write its own skills. And I think this is actually going to be pretty big with AI. GIF keyboard with an AI. You thought emojis were good enough. No, we need to share GIFs with the agent. I don't think this is on the internet because it's not replying, but the agent will actually reply with a GIF too.
Is there already an answer, right?
What?
Is there already an answer?
No, there's no answer. And I don't think this is actually online right now. I didn't get to test this before we sat down. Oh, no, there was. Yeah. The virtualized one is not as good as an actual phone. There we go. Oh, there we go. Yeah, so I mean, we thought emojis were fun, right? But now we can talk with GIFs with the agent. There's these cool little things we can do with agents. And this is like, I don't know, 350,000 lines of code that I wrote in 6 weeks with an agent. And I've sat down, I've tested all these features like 3 times. I'm very OCD about that. I'm not even sure it actually works. So you can scope really far with AI. I'm one guy, and I was able to do that. So yeah.
How do you stay on top of the security for the AI agents when you're creating them for?
So that piece of software is a really good example because there's so many attack surfaces there. There's tons of API calls that makes that happen. There's a WebSocket that's persistent. There's VMs that the agents have root access to. Part of it is you just need to know what the attack surfaces are so you can tell the agent to look for it. But if you take that BibeSec skill and you tell the agent, hey, what's relevant to our project that isn't covered by this, you will get a very strong list. And if you just do that a couple of times, you can be pretty confident. So before I released this on the App Store, I did that like 6 times. I literally went through like a full week's of usage credits. And I didn't get what code is.
And that's a set of questions that you can also ask when it's got a prototype or when you're planning stage, right? It's like, what are the attack vectors?
Yeah, exactly. So it's, I was talking about earlier, you keep coming back into this loop of development. That's another thing you need to be thinking about as you go with security. Because in the age of AI, your security is going to be so much more important than it ever has been. So, any more questions?
And by the way, guys, I think Austin will be here around here for a little while afterwards if you want to come and chat with him a little more one-on-one. Austin, was there anything else you wanted to show off, or do we want to?
You have a question?
No. What's the best way to connect people?
LinkedIn, Austin D. Wolf. Probably just going to be the easiest way.
Austin DEWOLFE.
Oh, I didn't
Yeah,
find my
yeah.
name tag today, I'm sorry.
Yeah.
Usually do, yeah.
Can find it there.
DEWOLFE should be the.
But then Austin, I think we also have his LinkedIn on the event bio, so you can go reach out to him there. And like I said, we will be sharing the slides from this presentation in the next email. Actually, Austin, if you could pull the QR code back up, last QR code from the calendar deck.
Oh, I forgot to show this. This was the game that was
That's all right.
actually
That's
developed.
all
This
right.
was really important. Thank you.
Yeah.
This is the game that was developed with that with those prompts, right? And it's bad. It's really bad, right? Like, but you know, it's also written in JavaScript, and we have a world order here, and we're rendering stuff past it. So they definitely make lots of mistakes. But the spatial audio actually does work. It's pretty accurate. It's kind of hard to hear. But while around this building, there's some spatial audio in there, so it's able to do these.
This was the result of the deep research.
Yeah, the deep research is the spatial audio, the ray traced audio we were talking about. And Claude one-shotted that feature. The rest of it, Minimax kind of didn't do too good on. Let me pull up the QR code for
Right, while he's doing that, everyone give Austin a huge round of applause.
Is it this one?
No, that's Michael's LinkedIn. Go like 10 slides back.
I think I actually moved one back. So
Go like
this
10
is so
back.
hard to do from this angle.
There it is. Yeah. All right, folks, we are basically at the end of the formal programming here. Don't have to leave by any means. We still have quite a lot of pizza. Please take some more. But thank you guys all for coming, spending your Friday with us. I really hope it stopped raining by now so you guys can get home. And I'm pretty sure the concert has started, so at least the traffic probably won't be as bad getting out of here. Now, if you want to stay up to date on future AI Texas meetups, and if you want the slides from this meetup, please scan the QR code, join our mailing list. We will also, thanks to our friend Alex, who has actually been recording the Austin session this whole time, we will have a YouTube video of this that will be posted on the AITX community YouTube. That link will probably also be in one of the upcoming email blasts.
And go to the Android App Store and get my app, Pocket Clause.
That too, yeah. Gotta let some free promo in. Folks, like I said, I think the space out there is open for networking afterwards. We are probably in the next like 10, 15 minutes going to start trying to empty out of the room here, just so we can clean up and be super respectful of our space here. But everybody, thank you so much for coming.